All right, so the point of this notes video is not actually going to be to complete much of the notes, but what you can see here is I've kind of superimposed a graph of our table on the top of the notes. So this is what your notes look like, but what we're going to deal with is taking that table that you see here, and what I've done, and what we'll do in class with the graphing calculators, is I've moved it into Desmos. Okay, so what we're going to be doing is playing around with what happens when we plot these points and it kind of looks like a function that already exists, and how can we figure out what that function is. So what I did is I plotted each one of those points. You'll see that these points line up with the points that are on your notes. And I've plotted them on the graph, and I've adjusted my window. You can see that in settings here, if you look at the x-axis, it goes from -10 to 3, and the y-axis goes from 40 to 90. So I've adjusted it so that I can actually see these points. And what you're probably noticing is that these points sort of look like they're mapping out a function that might already exist, right? It looks like it might already be a cubic function. So what we're going to figure out how to do tomorrow with the graphing calculators is we're going to figure out how to take that table and turn it into an equation of a function. And I'm going to show you what that looks like here on Desmos, but obviously tomorrow we'll use graphing calculators because that's what you're going to use on the Regents exam. So what I'm going to do is I'm going to say I know that there is a function that exists, and I'm going to call it y1. The reason I'm going to call it y1 is because the table of values that has my y coordinates in it is called y1. So I know that a function exists that is called y1, and this is something that is specific to Desmos, so don't worry too much about the notation on here. I'm going to use this symbol, which indicates that I'm trying to determine a regression equation. So the equation that I'm trying to figure out is not going to be the exact equation. It's going to be an approximation of a function that would map these points. And the type of function that I want to know about is a cubic function, because it looks like this thing bends twice. It looks like a third-degree polynomial. So what I'm going to do is make up a third-degree polynomial that has places where coefficients could go if I knew what they were. So for example, the first term of a third-degree polynomial would probably be some number and x to the third, right? But I don't know what that number is. And the thing I have to be careful of here is I got to call it x1, because again, you're going to notice that in our table, the x column is labeled x1. So I'm telling my function to use the values from this table, like programming it. So here's what we're looking at. I don't know what the coefficient is that should go in front of my x to the third term, so I'm leaving it blank. I'm going to let the computer try to figure that out, all right? Now I know that a third-degree polynomial has an x squared term as well, so plus, well, I don't know what that coefficient's going to be, but right now I'm going to call it just x1 squared. All right, it's probably going to have a squared term, right? And it'll also have some x to the first term, and it should have some sort of constant on the end. So what I've done is I've left spaces where Desmos can tell me what these numbers should be. Desmos is saying, well, it looks like your lead coefficient, if it is a cubic polynomial, would be this number. And it looks like your second coefficient, the coefficient of the x squared term, would be this number. And the coefficient of the x to the first term is that number, and the constant on the end would be that number. And if those were all the numbers, now you can sort of see what that function would look like. And it looks similar to what we thought that it might look like. My graph is a little rougher. But what we've done now is we've given the equation of a polynomial that maps these points best. If these points do in fact map a cubic polynomial, then this is the best approximation of what it could be. I could do the same thing. I could say, maybe I said that I thought it was a quadratic, and I did the same thing here, except if it was a quadratic, then I wouldn't need this x to the third term in front, right? So what I could do is I could just delete those, and I could say, I think, oh, I deleted the wrong thing. I think that it's a quadratic, not a cubic, so I'm just going to start there. Well, this is not a very good approximation because it looks like the function that they build for you, if you guess that it's a quadratic, doesn't map the points very well. So all I need you to do here is just see what I've done and understand what we're going for here, because in class we're going to practice doing this with some different tables of values, but we're going to be using the graphing calculator. So what we're going to do is we're going to put some points on a graph, and all using the calculator, we're going to figure out what function best maps those points.